Right now, you might be reading this alone, in a room, on a couch, with no one else in sight, and later tonight, you might eat alone, walk alone, sit with your own thoughts for hours, alone. That feels unremarkable. It isn't. For nearly the entire span of human existence, being physically alone, truly alone, out of sight and earshot of every other human, almost never happened. Not for a night, not for an hour. In most environments, it would have been a death sentence. In 1992, evolutionary anthropologist Robin Dunbar, then at University College London, published research examining the social structure of early human groups. He found that Paleolithic bands typically consisted of 25 to 50 individuals, nested inside larger tribal networks of roughly 150 people, a number now known as Dunbar's number. Below a certain group size, Dunbar's data suggested, human survival odds dropped sharply. Isolation wasn't a lifestyle choice. It was a statistical risk. Here's the disruption. Solitude, the thing modern humans sometimes crave, was almost biologically unavailable to your ancestors. And understanding why will change how you see every quiet, isolated moment in your own life. In 2009, primatologist Robert Sussman, at Washington University in St. Louis, analyzed predation records across primate species, including early hunters. He found that solitary individuals, separated from the group even briefly, faced dramatically higher rates of predation than those who stayed within a group's visual range. A lone body was easier to stalk, easier to corner, easier to kill. Group presence wasn't comfort, it was armor. But the danger wasn't only external. In 2003, anthropologist Sarah Blaffer Hrdy at the University of California, Davis studied cooperative breeding patterns among hunter-gatherer societies. She found that early human infants required constant, near-total physical proximity to caregivers, not just for feeding, but for basic survival. Unlike most primate infants, who could cling to their mothers independently, human infants were born with underdeveloped motor skills, unable to hold on, unable to follow. A caregiver, more than a few meters away, even briefly, put an infant at serious risk. Hrdy's research suggested something striking. Solitude wasn't just dangerous for adults, it was structurally impossible for the very young. That's not the whole story, though, because if physical danger were the only reason humans stayed close, isolation should have become easier the moment tools, fire and shelter reduced external threats. It didn't. In 1966, psychologist Harry Harlow's earlier primate studies, later re-examined by Hrdy and other researchers studying human parallels, showed something the original danger explanation couldn't fully account for. Infant primates, isolated from all social contact, even when given food, warmth, and physical safety, developed severe psychological and physiological distress. Isolation alone, with every physical need met, was enough to cause measurable harm. Something deeper than physical protection was at stake. In 1996, neuroscientist Jaak at Bowling Green State University identified a specific brain system he called the panic grief system, a neural circuit triggered by social separation and calmed almost exclusively by social reunion. Panksepp found this system activated the same neurochemical pathways associated with physical pain. Being cut off from others, his research suggested, wasn't processed by the brain as an inconvenience. It was processed as an injury. That reframed everything researchers thought they understood about early human isolation. The threat wasn't just a leopard in the dark or a caregiver too far to reach. The threat was a nervous system, hardwired over hundreds of thousands of years, that treated separation itself as a survival emergency, regardless of whether any actual danger was present. In 2015, neuroscientist Cacioppo at the University of Chicago spent decades studying loneliness in modern populations and found that perceived social isolation activated the same stress response systems the body uses during physical threat. Elevated cortisol, disrupted sleep, weakened immune function. Cacioppo's research suggested modern loneliness wasn't a new problem. It was an ancient alarm system, still firing, long after the original predators disappeared. Group defense explained why early humans avoided physical isolation. Infant dependency explained why caregivers couldn't create distance even briefly. But Panksepp's and Cacioppo's research explained something the earlier findings couldn't: why solitude still feels distressing today, in a world with no predators left to fear. The human nervous system, it turns out, was never built to register aloneness as neutral. Not for infants. Not for adults. Not even now, when every physical danger that shaped that system is gone. You feel a version of this every time a quiet room starts to feel heavier than it should. Every time being unreachable, even for an hour, creates a low, nagging unease you can't quite explain. That isn't oversimplification. It's a system built across hundreds of thousands of years of never actually being alone. Still running, still treating distance from others as a kind of danger. Because for almost the entirety of human history, it always was.